Good morning, guys. I'm gonna try to make this as quick and as non-boring as possible, but that's gonna be kind of difficult to do behind a screen where you can't even see my face. Alright, so what I'm gonna do is I'm gonna go through this lecture and I'm gonna kind of teach it to you. You could kind of teach yourself with it, but I'm just gonna hit some high points. And I'm also going to be showing you what to highlight. So no, I'm not gonna pull it up as a PowerPoint. I'm going to keep it just like this so we can highlight as we go. Okay, so we are going to start talking about heat, energy, and temperature. Here's just some pictures for you for energy. So what is energy? I need you to highlight the ability to do work. Energy is the ability to do work. If we are doing work, we are using energy. You should know that because a lot of you play sports, and if you don't play sports, you at least walk from class to class. So you are doing work, and it is using your energy to do it. Energy is transferred from one object to another when work is done. We are going to talk about energy transformations later in the week. First, we got to figure out what energy is and the different forms of energy before we can talk about how they're transferred. So we will go back to this statement later. What is energy measured in? Energy is measured in a joule. And for you middle schoolers, not a J-U-U-L, a joule, a J-O-U-L-E. It's named after this guy right here. But one way that y'all always remember it is if I say not a J-U-U-L, joule. So, the energy that the unit that we measure energy in is a joule. When we are doing calculations, the unit will be a capital J. Okay, next, what is potential energy? You've probably heard of this before. Potential energy is energy that is stored, and it depends on its position. So the higher off the ground an object is, the more potential energy they have. Think about a slide. If you're on, or think about a roller coaster, either one. If you're on a roller coaster or a slide that's not very high off the ground, you're not going to go very fast when you go down because you don't have a lot of stored energy. If you're on a slide or a roller coaster that goes super high up in the air, when you start going down, you're going to pick up speed because you have a lot more of that energy that is stored that wants to turn into energy in motion, which we'll talk about in just a second. Okay, what is gravitational potential energy? That's what I was basically just explaining. It's potential energy that depends on an object's height above the ground. So the higher up you are, the more GPE you have, gravitational potential energy. It depends on your mass and your height, and they are directly proportional. We're not going to highlight this, but if I was there, I would say, what does directly proportional mean? Directly proportional means if your mass goes up, your gravitational potential energy goes up. If your height goes up, your gravitational potential energy goes up. This right here, GPE equals mgh, is how we will calculate this. And what it is saying is gravitational potential energy equals mass times your gravitational acceleration, and if I was there again, what is that? 9.8 meters per second squared times your height. So this right here is always going to be 9.8 meters per second squared, as you can see right here, meters per second per second. Okay, now let's talk about kinetic energy. Kinetic energy, and let me flip my notes to know what I wanted you to highlight. Kinetic energy is energy of a moving object. Okay? And this depends on its mass and velocity, and we can also say mass and speed because we know that velocity is just speed with a direction. So this depends on its mass and its velocity. They are directly proportional, which means mass goes up, kinetic energy goes up, velocity or speed goes up, kinetic energy goes up. Right here is going to be our formula for calculating kinetic energy. Kinetic energy equals half times your mass times your velocity squared. So, step one, what I would do, square my velocity. Next, multiply that by mass, whatever that is, divided by 2. Okay? And this one right here, which of the two factors, mass or velocity, will have a greater effect on kinetic energy? You should be able to figure this one out just simply because velocity is squared. Your mass is not squared, so it's not going to have as much of an impact on your kinetic energy as your velocity will. Next one, law of conservation of energy. We talked about this when we talked about law of conservation of mass or matter. Energy cannot be created or destroyed. It is only transferred or transformed from one form to another. So, what that is saying is, as an object falls, it starts at potential energy up at the top. When it's in motion, the potential energy is going to decrease while the kinetic energy increases, but the total energy overall is going to remain the same, okay? So what that means, potential plus kinetic is your total. Your total is going to stay the same. The only thing that's going to change is you're going to have 100% potential, and then it's going to change into 50-50 potential kinetic, and then eventually right before it hits the bottom while it's still in motion, it'll be 100% kinetic, 0% potential. Okay? And then here's that in a pendulum. And I would like for you to highlight all of this, and all of this. I just can't do it on the computer right now. So basically what this is saying is 100% potential, 0 kinetic. 50-50, or I'm sorry, not 50-50. It's all the way at the bottom, so now it's going to have max kinetic and minimum gravitational, because we know the further off the ground it is, the more potential it will have. And then as you go back up, you're going to have max potential and 0 kinetic again. Okay, so the total energy in this pendulum stays the same. The only thing that changes is if it's gravitational or kinetic. Alright, and let's see if this is going to work for us. No. Darn. Okay, well, this is just a pendulum that swings, and right here it shows you kinetic versus potential. Okay, so let's look at this picture. So this one right here is showing you that you have high potential energy as you are way up here off the ground, and low kinetic, and then it picks up speed. Down here is going to be going super duper fast, so it's going to have max kinetic, minimum potential. And then as it goes back up off the ground, it's still going to have high kinetic energy because you're still going to be going super fast on that roller coaster, but you're also going to have some potential as well, because as you see, you're not on the ground down there. So this, I would say this is about 75-25, 75% kinetic, 25% potential. Alright, so what are some other forms of energy that we are going to talk about? First one we're going to talk about is heat energy. I hope to the heavens above that everybody in this class knows what heat is. So, heat energy is caused by the internal motion of atoms. If you put your hands together and you rub them super fast, they're going to heat up. That's friction. So the internal motion, the more that something moves, the hotter it's going to get, the more heat energy it's going to have. Okay. The next one is chemical energy. Chemical energy is caused by the breaking and forming of bonds. So one that really gets people is food. They don't understand that food is chemical energy. The reason food is chemical energy is because when you eat it and it starts going through your digestive system, it actually breaks those chemical bonds in that food, and those chemical bonds release energy, and that is where you get your energy to get through the school day. Most people understand that a match has chemical energy because they know that some sort of chemicals are in the tip of that match. It's actually phosphorus that's in the tip of most matches. So that one usually does not confuse people. And 2 more slides, woohoo! Electromagnetic energy is the next one. And electromagnetic energy is associated with moving charges. So we know that in order to be charged, we have to have electrons. So this is those moving electrons that is causing this electromagnetic energy. And there's a bunch of different kinds. In the 8th grade class, we go into every specific energy form, talking about light and electricity and everything. But we're going to put it all in one big and call it electromagnetic energy for this class. But it takes into account electricity, light, x-rays, radio waves, basically anything on the wavelength chart. And the last one we're going to talk about today is nuclear energy. We talked about fission or fusion already in this class. Fission is the splitting of a nucleus. Fusion is the combining. Okay, and we can remember that because if you fuse something together, you put it together. My back is fused together, so I cannot bend over. It's all like soldered together. So this is caused by changes in the nucleus of an atom. So some things with nuclear energy, and nuclear energy is stored, so it's potential. A nuclear power plant is a great example of this, because we know that there's nuclear energy there. It's storing up all that energy from those splitting nuclei to power our world. And that is all that I have for you today. So the next thing that you should be working on is the worksheet that the sub has. And when you are done with that, I would like for you to please turn it into the 3rd period box. And I will see you guys tomorrow. Please behave. If I get a bad report, it'll be a bad Tuesday for you.